Hello, my name is Dr. Jason Bruck and I'm an Associate Professor of Biology here at Stephen F. Austin State University. On behalf of my colleagues at Oklahoma State University and Dolphin Quest, I'm pleased to update you on the progress of our cetacean breath collecting UAS, codenamed PHASM, or Passive Health Assessment, in sea mammals. Both large and small whales present unique challenges in blow collection by UAS. However, solving many of the problems that face small cetacean blow collection can improve the chances for specimen capture in large whales. In all cetaceans, sample collection is reduced by the forces of downwash created by rotary propellers. This is ameliorated by the use of fixed-wing systems for specimen capture. Given the close approach of fixed-wing systems, and knowing we would use a device with a larger visual profile than a typical rotary UAS, it became necessary to use psychophysical methods to determine the effective field of vision in small cetaceans to optimize visual stealth. Mapping out the visual fields of bottlenose dolphins revealed a blind spot in the dorsal posterior region of the animal, ideal for close approach fixed-wing operations. The next step in our process was to develop a flight protocol for these close approaches. This was achieved by modeling and then successfully replicating the blow field of bottlenose dolphins using a technique called particle image velocimetry, as well as building a chuff simulator that accurately and reliably produced a dolphin blow that could be used to test different UAS designs as well as perfect approach techniques. As we moved forward in this process, it became clear that even though a fixed-wing approach was superior to rotary systems for collection without downwash, specimen capture amounts were still not sufficient. So we developed an active collection siphon that could mount onto our PHASM platform. This greatly improves sample capture in both laboratory tests as well as with animals in the field. This siphon will also likely improve specimen capture in large whales as well. As collection teams practiced with the chuff simulator in Stillwater, Oklahoma, we also conducted behavioral response tests at Dolphin Quest Bermuda using common off-the-shelf UASs compared to our first version of PHASM. As you can see, the early PHASM system performed poorly in perceptible noise generation, which led to a revision of the system. In 2023, we made our first collection attempt at Dolphin Quest Bermuda with an open ocean trained animal. Due to weather and tides, we were only able to perform a few passes, none of which saw successful collections. However, we did learn that the system could respond well in relatively adverse conditions, and with practice and more opportunities, collection could be possible. In the summer of 2024, we traveled to Dolphin Quest, Hawaii, this time with a quieter, more aerodynamic system, with the siphon now incorporated into the body of the plane, and we used the open lagoon of the Hilton Waikoloa as a test bed for sample capture. Here in Hawaii, we were met with success after 3 weeks of strong winds and practice both with timing and approach. We used grade 50 paper soaked in pH indicator fluid reactive to the pH of dolphin blow to indicate successful acquisition. This June, we hope to begin wild tests where samples will be analyzed locally, initially for genetics and eventually for other health indicators.